We've discussed series at length. Just to remind you, an arithmetic series has a common difference which is its defining feature, and a geometric series has a common ratio as its defining feature. However, there's still half a battle that we have not fought, which is the sequences side of things. An arithmetic series of n terms has first term a with common difference d, so it's a plus d plus a plus 2d plus and so on, all the way to the nth term. Because the first term had no common differences added to it, the last term would have n minus 1 common differences added to it. Similarly, for the geometric series, it starts off with a, and the second term would have a times the common ratio, and the third term would have a times the common ratio again, and so on all the way until the nth term, which has n minus 1 common ratios, because the very first term had no common ratios multiplied onto it. We've used the alphabet n to denote the last term. Remember, the terms of a series, regardless of arithmetic or geometric, must be a positive thing. You can have one term, two terms, three terms, four terms, and so on, but you can never have a negative number of terms. Even then, you can't have a fractional number of terms. You can't have half a term. You gotta have a discrete number of terms. So we usually use the alphabet n to represent the very last term of the series. Let's define the alphabet k to represent a term which is not necessarily the very last term. Now, with that said, let us abbreviate AP to be arithmetic progression and GP to be geometric progression. Let the kth term of an arithmetic progression be the first term plus the previous term plus the common difference. With regards to the geometric progression, the kth term of a geometric progression is given by the first term times the common ratio to the power of the previous term. In the geometric progression of 27, 18, 12, 8, and so on, find the common ratio, find the 10th term, and find the nth term. Once again, in the geometric progression of 27, 18, 12, 8, and so on, find the common ratio. B, find the 10th term. And C, find the nth term. To find the common ratio of any geometric progression, we simply take any successive term divided by the previous term. In this case, 18 divided by 27, divided by 18, and 8 divided by 12. So we get a common ratio of just 2/3. How do we find the 10th term? Well, we know that any term in a geometric progression is going to be tk equal to 8 r to the k minus 1. Since we want to find the 10th term, but what's the a value? The very first term of this entire progression is going to be 27. And what is the common ratio value? 2/3. And we could leave it like that actually, but let's actually calculate it out. And how do we find the nth term? Because we know that the kth term, or any term, is given by r to the k minus 1, the nth term has got to just be replacing k with n.